Hello everyone, happy evening, a very good evening. I hope and I believe all of you are doing well. A quick note whether the audio visual is all good. Yes, am I audible and visible everyone? A quick nod there. I hope I'm able to see the live chat. Just a minute. Yes, so I was not seeing the live chat. Now I can see it. Thank you so much, and welcome to the today's YouTube live session. This is like very unplanned, but this is something that was remaining from the class that we had yesterday on the Unacademy app, where we discussed the first part of PSM Numericals. So part 2 was remaining, and I told you that we will do it in one of the sessions soon, and that's the reason we are doing it at this odd time and as a very unplanned session. You can watch it later as well. It would be available as a recorded session as well. In the today's session, the focus is going to be on the biostats part, on some formula parts, some concepts, and again the focus would be on the previous year questions that have been asked in the recent years. The link for the part 1 I've given in the description. So for those who missed it as a live class, you can still watch it as a recorded class. It's a free class available on Unacademy app. You can use the code Dr.Nikita while you are trying to access that. Okay. So let's start with it, and just a few lines here, like since Dr. Happiness has put a query here, very tense and stressed, not able to complete the daily target revision, feeling short of time, and the day is just finishing. Absolutely, this is how it will go. It's going to happen. Before the exam, the 24 hours of the day will go like, in the blink of an eye. And once your exam is over, all the sleep that you used to get before will be gone. All the time that was running very fast, now it would become very slow when you would actually not have anything to do, right? So I think this is the best part, where you are super busy. When we are busy, time flies. We do not realize the time. That's actually a good thing. You would realize it only when you will try to see it in the hindsight, right? So do not get stressed, do not get anxious, just focus on the important topics in these last days. Do the previous year questions and the related topics first for any subject that you are trying to revise. Then time permits, do the rest of the topics. Okay, do the rest of the topics, right? Don't try to do everything that you have been doing in the last year. It's absolutely not possible, and have some faith on your memory and the brains. It will help you answer the rightly and correctly in the exam. Have that faith. Okay. So let's start the initial part we had discussed. So I'll quickly jump on to this part. I hope all of you remember this was the last question that we had discussed in the yesterday's class, calculating the Pearl index. That was basically the contraceptive failure pregnancy wala. Okay, so it was 10 upon 24 into 1200 is what we had got. So the answer was 5. So now starting with the standard normal distribution curve, also called as the Bell's curve. So tell me, what do you think would be the answer to this one? Area under standard normal distribution curve is how much? Short 150 will be enough for the last days. Very essential is what I would say, though not enough, but it is essential, and you can try to do it in just 2 days, the entire short 150. What is the area under curve for a normal distribution curve? It is 1. Okay, the area under curve is 1. So remember that for the normal distribution curve, which is a bell-shaped curve, in the center, basically what is there for the normal curve? The mean is equal to median is equal to mode. And what is the value of that? What is the value of that? Mean is equal to median is equal to mode, and the value is 0. For area under curve, it is 1. Okay, the area under curve is 1. Standard deviation is 1. Now look at this, a similar question that we have here. What do you have here? True about Bell's curve is which of the following? Sorry for it got disconnected in between. I hope I am audible and visible now. Yes, okay, that's great. So which of the following is true about the Bell's curve? Which of the following is true about the Bell's curve? What is that? Is it skewed to the left? No, it's a bell-shaped curve with the equal distribution there on either side. So this one is false. It has a mean of 1. Right now we said that mean is equal to median is equal to mode, that is 0. Standard deviation हमने अभी बोला is equal to 1. Area under curve is also 1. So remember, as is 1 here in the normal distribution, that is area under curve, standard deviation is 1. And so all these are incorrect. So this becomes the correct one, that is variance is equal to 1. Variance is SD square. Okay, variance is SD square. So 1 ka square, this will be 1. Okay, so the answer is variance is 1. Next one, in positive skewed deviation, which of the following is true? So I'll tell you some simple tricks to remember this, the positive skewing and the negative skewing. Absolutely right. So positive skewing will have the correct answer as A. What does that mean is, see, whenever you have the skewing to any side, look at the graph here and look at the graph here. Where the tail is going, where the tail of the graph is going, it is that skewing, that deviation. So if the tail is going towards the left, that is the negative side. Okay, so that this is negative skewing. If the tail is going towards the right side, that means it is positive skewing. And wherever the skewing the tail is going, that is where you would have the mean located at that end towards the tail. Right. So look at the graph here. Positively skewed, matlab the tail is going towards the right. Negatively skewed, matlab going negative towards the left. And wherever is the tail, that is where the mean is. So when I say positive skewing, that means mean will be positive. That means mean will be the maximum. Negative skewing, negative tail, that means the mean will go towards the negative side. That means it is mean will be the minimum. Okay, negative skewing. So when I say that mean is the maximum, बीच में आता है median, फिर आता है mode, right? So the first one is the mean, then is the median, and then is the mode. You can actually remember it like जैसे dictionary में ये words आएंगे spelling wise, MEA, MED and MOD. Okay, so that is what is the positive skewing and the negative skewing. So tail towards the right, positive skewing. Mean will be positive. So mean, median, mode. Okay, dictionary में जैसे arrange करेंगे वैसे करना. And negative skewing, tail towards the left, mean less than median, less than mode. Here the question is for positive skewing. Positive skewing, mean will be positive. That is mean will be maximum here. So mean more than median, more than mode. That is what will be the answer. In none of the else, you have a mean which is the maximum. So automatically the rest of the options are out. Okay, the rest of the options are out. Is this clear with everyone? So positive, mean maximum, negative, mean is minimum. Then you have mean, median, mode in that direction. Okay, and a normal distribution has no tail. Basically, it's a bell-shaped curve, also called as Gaussian curve, and mean is equal to median is equal to mode is equal to 0. Okay, thank you so much. Now, in a set of data with highly variable values, you know, very high values to low values, बहुत ज़्यादा difference है in the values that we have in the data. What is the best measure of central tendency in that case? What is the best measure of central tendency in that case if they are very, very variable values? एक 10 है तो एक 1000 है वैल्यू, बहुत वेरिएबल है. इन दैट केस मीडियन इज द बेस्ट. Okay, median is the best measure of central tendency when it is highly variable. Remember that, very, very important. And next question, which of these is not a measure of central tendency? Which of these is not a measure of central tendency? No, it is the standard deviation. Absolutely right. So mean, median, mode, which we read together, they are the measures of central tendency. Standard deviation is a measure of dispersion of the data. You know how far the data is going from the central tendency. So remember that measures of central tendency, these are median, mode, mean, median and mode. And standard deviation is a measure of dispersion or variability or the spread of the data, right? So range, interquartile range, variance, which is related to standard deviation, all of this is a measure of dispersion. Measure of position, which measure the position of specific data in relation to other data in the set. You know, that is what is percentile. So when you get your scores in percentile, so it tells you that topper is 100 percentile, uske comparison mein where you are getting the score. So you are comparing with the other data. That is percentile. So these are the measures of position. What is your position as compared to someone else in the test? So percentiles, quartiles, centiles, Z scores, these are the measures of position. Measures of central tendency location, basically they define the center. Okay, they define the center. Okay, is this clear with everyone? So standard deviation is a measure of dispersion. It is not a measure of central tendency. Next one, which of these is not a parametric test? Now coming to the test of significance, which of these is not a parametric test? No, correct. So I see Anjani getting it right. Arpit, correct. It is the chi-square test. It is the chi-square test, which is not a parametric test. The rest of them you see are related. T-test, Z-test, ANOVA test, all of these are related because these are used for quantitative data, parametric test, normal distribution, right? This one is not for quantitative data. This one is for qualitative data. This is non-parametric, non-normal distribution curve. Okay. So remember that for quantitative data, quantitative, a lot of T's, T's and T's. For quantitative data, it is the T-test. For qualitative data, it is the chi-square test. Okay. T-test is used when you have two groups. When you have more than two groups, then you have ANOVA test. So ANOVA is for quantitative data, more than two groups. Okay, more than two groups. Now let's have a look at the next one. Which of the following is true about the chi-square test? Which of the following is used for a chi-square test? True about chi-square test is, yes, no. So this is a trap laid here and this is a previously asked question. The correct answer here is D. Chi-square test can be used even when there are more than two groups. In the quantitative test, we have the T-test when it is two groups. When it is more than two groups, it is ANOVA test. But here, for qualitative data, proportion, association ke liye, we can use chi-square test even for more than two groups. And remember that we just now said that chi-square is not non-parametric test. It is used for non-normal distribution. It does not measure the strength of association. It does measure the association, but not the strength of association. How much is it associated? That it will not tell you. So remember that if it measures the association, yes, but it does not measure the strength of association. Remember that. Okay, so for association and proportion, we do use chi-square test, but it does not measure the strength of association. That is what it is. So chi-square test is for 2 groups, for more than 2 groups as well. Qualitative data, so remember it is for qualitative data. Non-normal distribution, so it's a non-parametric test. It is used for qualitative data like nominal data, categorical data, okay, and it is used for association or proportion. Wherever you see that, then you use the chi-square test. Next one, what is this table summarizing? The parametric and the non-parametric test. Parametric test, quantitative data. How do you know it's a quantitative data? You can measure and it has a unit. Like weight, this much kgs, 10 kgs, 20 kgs, 30 kgs. Blood pressure, millimeters of mercury, various values. Qualitative gender, male and female, right? You are just categorizing, categorical data. Blood group, again categorizing. So that is qualitative. It does not have a unit. So here in quantitative is where we get the mean, the standard deviation, the variance. In qualitative, you have the proportion, right? So proportion, percentage, fraction is what is the non-parametric test. It is for nominal or ordinal data. Example, student t-test, z-test, ANOVA test, also called as the f-test. And here in non-parametric, you have the various other tests, which are the chi-square, Fisher test, then the Wilcoxon test. All these come under your non-parametric test. No need to go into the details of this test. Most important, you will be asked questions like t-test kahan use karenge, chi-square test kahan use karenge. Okay, so questions like this. The significance of difference between proportions can also be tested by the significance of difference between proportions. Whenever you see proportion, remember it is the chi-square test. Okay, it is the chi-square test. So for proportion, it is going to be the chi-square test. I'll tell you about the paired t-test and the unpaired t-test. That is what is the next question. So with how do you define a paired t-test? How do you define a paired t-test? Is it A, is it B, is it C? What is the first option that you rule out here? B is the first option that you rule out here because t-test is quantitative. Okay, remember it's not for qualitative data, that is not for proportions. For that we have the chi-square test. Right, now what is the paired t-test and the unpaired t-test? Pairing matlab this is before and after the intervention in one group itself. So let's say there's a group of people with high blood pressure. You measure the blood pressure before giving a drug. You give a drug for 1 week and you tell them come after 1 week, we'll measure the blood pressure again. So before and after intervention in the same group, that is going to be a paired t-test. Unpaired matlab this group of people with high blood pressure you have divided into 2 groups, group 1 and group 2, and you have given 2 different interventions. एक में दिया है drug A, एक में दिया है drug B, and then you compare. That is unpaired. So unpaired means they have different interventions. So pairing is the before and after. So test used to assess the quantitative observation before and after. This is a paired t-test. Test applied when separate observations are made on individuals of 2 separate groups and these need to be compared. Then it is unpaired t-test. Okay, then it is unpaired t-test. Okay. So remember, pairing is just one group, but it is before and after the intervention. Okay. Next one, a previously asked question. What do you think will be the answer to this one? A survey was made to assess malnutrition among children. 100 children from rural area and 100 from urban were taken. 30 from rural area and 20 from urban were found to be malnourished. Which test can be used to find out if this difference is significant? Absolutely right, it is the chi-square test. Why? Because what kind of data is it? Is it a quantitative data? You are just seeing ki how many children are malnourished out of the 100 children that we have taken. So it is a fraction, it is a proportion, it's a percentage. Malnourished hai, nahi malnourished hai. We are categorizing the children into that. So this is a qualitative data. है या नहीं है. You are not measuring it in any ways. So qualitative data, chi-square test. The rest of the three, they are for the quantitative data. So automatically these are out. Okay, easy, right? So remember that this is chi-square test. You are not actually measuring anything. Another example of chi-square test, they can tell you that we have people, 10 people with lung cancer, and we see that how many of them are smokers, how many of them were non-smokers. So basically you're looking at the association of smoking with lung cancer. So even this one will be the chi-square test. Association, proportion, it is chi-square test. Remember that. Standard error of mean, agar bola mean is for quantitative data, then we will use the quantitative wala test. Okay. All right. Next one. What does the scatter diagram represent? Scatter diagram represents the frequency of occurrence, the trend over time, correlation, association, or none of the above. Abhinay, part 1 ka link I've given in the description of this video. You can watch it from there. Right. Remember that scatter diagram is a correlation and association. Right. So there are two variables that we are trying to see, and we are seeing that how much they are correlated. Jitne points single line mein honge, the points coming in a single line going upwards, it's a positive correlation. Right. Jitne points scattered honge, the points would be scattered. It means that there is no correlation in the two variables that we are trying to see. Again, an example like smoking, lung cancer. Okay, so how is the correlation? So positive correlation means there is a relation between the two. Negative correlation means there is opposite correlation. एक बढ़ेगा तो दूसरा कम होगा. Negative means it is going downwards like this. Okay, so one is high, the other is low. One is low, high, the other is low. Okay, so that is what is negative correlation. Positive correlation means this is also high and this is also high on the x and the y axis. Okay, so remember that scatter diagram tells you about correlation, the trend over time. What is the trend over time? Let's say for the COVID number of cases. How is it increasing? How it is decreasing? We basically give by the line diagram. Remember, for that we have the line diagram. Okay, for that we have a line diagram. Okay? Trend over time is basically by line diagram. Next one of the recently asked questions in the NEET PG exam. What do you think would be answer to this one? In a normal distribution, if mean is 200, standard deviation is 20, 68% population lies within what range? Very good. Maitri, Ishan, Anjani, correct. All of you getting it right. This is option A. So very, very important. In a normal distribution, one standard deviation plus minus one standard deviation. If this is the mean, you have mean plus one standard deviation, mean minus one standard deviation. The percentage of population that we have is 68%. How much do we have in two standards deviation? Two standard deviation covers how much? Two standard deviation is 95%. And how much do we have in the three standard deviation? It is 99.7%. So remember that it is 68, 95, 99.7 for plus minus one standard deviation, plus minus 2 and plus minus 3 standard deviation. They've asked you here 68%. 68% means what you have to do is mean plus minus 1 standard deviation. Mean is 200, so minus 1 standard deviation is 20. So 180. 200 plus 20 is 220. Okay. 160 to 240 would be how much percentage? That would be 95%, because this is plus minus 2 standard deviation. 200 minus 40, 200 plus 40, it is 2 standard deviation is what we are seeing here. This is going to be 3 standard deviation. Okay. Now, suppose if I ask you how much percentage of population lies when you have mean plus 1 standard deviation. The question is how much population does lie in the mean plus 1 standard deviation. How much would it be? We are just talking about mean plus 1 standard deviation. So half of 68, that means 34. 34% mean plus 1 standard deviation, and 34% will be mean minus 1 standard deviation. Okay? Is this clear with everyone? So you have to actually divide it into half and half. मैंने सिर्फ plus 1 standard deviation बोला, not plus minus. Okay, not plus minus. Next one. In a normal curve, what is the area that comes under 1 standard deviation? Just now we saw 1 standard deviation is how much? It is 68%. 95% is 2 standard deviation. Okay, 95% is 2 standard deviation. Okay, going on to the next one. The variation in a data set is compared to that with another data set by using which of the following? This is a previously asked question, so this is important. Now, we are talking about the variation in a data set is compared to that of the another data set by, the answer is coefficient of variation. Okay, it is a coefficient of variation. Look at this one. What is the difference between a coefficient of variation and the standard deviation? See, when you are asked what is used to measure the dispersion of data in a single data set, right? This is the dispersion we compare with the standard deviation. अगर single data set में dispersion देखना है तो standard deviation. When you want to compare the variation of different data sets, then you use the coefficient of variation. Coefficient, remember, is like comparison of variation. Standard deviation, S, is for a single data. Coefficient is for comparison. So this is a relative measure of dispersion. This is an absolute measure. Here it's relative, comparing the two, one only absolute. It measures the ratio of the standard deviation to the mean. What is the formula for coefficient of variation? ST upon mean into 100. Okay, ST upon mean into 100. So look at this one. The coefficient of variation is a statistical measure of the relative dispersion of data points in a data series around the mean. It is a relative variability ka measure, also known as relative standard deviation. Relative matlab comparing. And the formula is ST upon mean into 100. Remember, the formula for coefficient of variation is ST upon mean into 100. Okay, I hope this is clear with everyone. Next one. See, in that option, Sayantani, you did not have the option of 34%. So that was easy. Isliye we went ahead with 68 only. Okay? Another one, look at how the question is changed. Calculating one variable using another variable. What is done by which of the following? Coefficient of variation, coefficient of regression, correlation, या coefficient of determination. You are calculating one variable using another variable. So, जो variable से हम दूसरा variable निकाल रहे हैं, that's the independent variable. The one which we are calculating from it, it is dependent variable. That is coefficient of regression. Okay, that's a coefficient of regression. Right, just remember these terms and write these down as one-liners. Okay, so when you want to compare the variation in two data sets, then it is coefficient of variation. When you want to take out one value from another value, then it is coefficient of regression, which could be a linear regression, which could be a logistic regression. It could be simple linear, multiple linear, right? So regression is basically to calculate one variable from the another variable. Okay, remember this point. Okay, next one. How will you define a p-value? We have tried to discuss this. Yesterday. Tell me, what do you think will be the correct statement here? P-value is defined as which of the following? Is it A, is it B, is it C, or is it D? So a lot of you struggle with p-value. Let me try to simplify it again for you. So remember, p-value is nothing but the probability. P P is the probability of type 1 error. What is the probability that type 1 error will occur? Okay. Now, what is the type 1 error? Is it false positive, true positive, false negative, true negative? What is type 1 error? Type 1 error is the alpha error. Okay. So remember that error is always going to be false. That is an error. True is not going to be an error. So type 1 error is false positive. Okay, please remember this point. So type 1 error, type 2 error. Type 1 error is false positive. This is false negative. You can remember this by when I write P, it has a single vertical line. When I write N, it has two vertical lines. What is true for the null hypothesis? The null hypothesis H0. Here the null hypothesis is true but rejected. Here this is false but accepted. How do we remember that? When I write T and when I write F. Now count at the number of the horizontal lines. T has single horizontal line. F has two horizontal lines. So remember that here the null hypothesis is true. Here the null hypothesis is false. And when I write true, when I write false, remember it is TR. That means it is true but rejected. False is FA. That means it is false but accepted. Okay, it is false but accepted. Right. So this is the easiest way to remember your type 1 error, which is alpha error, type 2 error, which is beta error. Right, alpha 1, beta B, second alphabet 2, false positive, false negative, true rejected, false accepted. So type 1 error is false positive. That means positive is the result that we are getting, and false means the actual thing is the opposite. That is what is false. So we are getting a positive result. That means probability of declaring a significant difference. That is what is a positive result. When actually it is not present. Contradictory, that's an error. Okay? Probability of declaring a significant difference when actually it is present. This is not an error. The two are going together. Probability of not declaring a difference when it is not present. Again, the two are going together in synchrony. So it's not an error. So B and C are automatically out. Probability of not declaring a significant difference when actually it is present. Not declaring a difference means the result is negative, but it's the opposite of the actual condition. That means this is false negative. That means this is type 2 error. Okay, that is type 2 error. Okay. Now, so P value is the probability of, what will be the answer to this? You get these type of questions. P value is the probability of, now this becomes very, very easy. P value is type 1 error. Okay. P value is type 1 error. So 1 error is null hypothesis single line, null hypothesis true but rejected. Remember, we are talking about the null hypothesis, not the alternate hypothesis. When the null hypothesis is true but rejected. Okay, TR, true but rejected. So the answer will be B. Is this clear with everyone? Right? And what is the power of a test? What is the power of a test? Power of a test is, जो सही है उसको find out करने के लिए, it is 1 minus beta. It is 1 minus beta. So by decreasing the beta error, we can increase the power of the test. Power of a test is 1 minus beta. Okay, 1 minus beta. So by decreasing the beta, we increase the power of the test. Right? Yes, so that was about the quick points in the most important points in stats. I have not covered the graphs wala part here. Of course, it is important. Do try to revise that as well before the exam. Okay, so that was for today, guys. Do watch the part 1 where we have discussed sensitivity, specificity, K, tricks and a few other formula. Do watch it. The link is there in the description as well. Okay. So thank you so much everyone for joining in even this late. That's really a good gesture, and I hope this will benefit you for the exam. And yes, goodbye, take care, keep studying, keep revising and keep winning. Thank you so much.